Imagine waking up one morning and finding your compass pointing south instead of north. Planes begin to reroute, satellites fail mid-orbit, power grids start to flicker and collapse. Migrating animals once in perfect sync with the planet's magnetic rhythms scatter in disoriented chaos. Solar radiation begins punching through Earth's atmosphere in places once considered safe, and suddenly, the invisible force field that protected humanity since the dawn of time, our magnetic shield, is vanishing. This isn't a movie, this isn't some distant sci-fi scenario, this is happening right now. Slowly, silently, and relentlessly, the Earth's magnetic field is weakening, and we may be heading toward a magnetic pole reversal. But what does that actually mean for life on Earth? Could it be the next great extinction event, or is it just a natural process we'll survive? Barely. Buckle in, because what you're about to learn might change the way you think about our planet forever. Beneath your feet, about 1,800 miles below the surface, the Earth's core churns like a furious cauldron. The outer core, a sea of molten iron and nickel, spins and swirls, generating a powerful electromagnetic field that shoots out of the poles and wraps around the Earth like an invisible cocoon. This magnetic field is not just for show, it's our planet's first and last line of defense against the cosmic chaos of space. It deflects solar wind, protects us from harmful radiation, and even makes GPS and telecommunications possible. Without it, Earth would be a scorched wasteland like Mars, stripped of its atmosphere and bombarded by high-energy particles from the sun. And here's the scary part. That field, our shield, is acting weird. It's weakening. Rapidly. Over the last 200 years, scientists have observed a dramatic 10% drop in the strength of Earth's magnetic field. Even more unsettling, the magnetic North Pole isn't where it used to be. It's racing from Canada toward Siberia at a rate of about 30 to 40 miles per year. That's like your GPS suddenly relocating magnetic north to the other side of the world. And historically, when the magnetic poles start to move this fast and the field weakens this much, a flip is usually coming. Yes, a flip. A magnetic reversal. A total swap where magnetic north becomes magnetic south and vice versa. It's happened before. In fact, it's happened at least 183 times over the last 83 million years. The last full flip, known as the Brunhes-Matuyama reversal, happened roughly 780,000 years ago. Since then, we've had a few close calls, brief, failed reversals known as excursions. But the planet has been relatively stable, until now. The South Atlantic Anomaly, a strange dip in the magnetic field strength over parts of South America and the South Atlantic Ocean, has grown rapidly in the last few decades. Some scientists believe it may be the early sign of a new reversal. And if it is, we're heading into uncharted territory, with billions of human lives, trillions in infrastructure, and the entire balance of nature at stake. So what actually happens during a magnetic pole reversal? Here's the terrifying truth, it's not a clean flip. It's not like one day north is north and the next day it's south. No, it's messy, chaotic. The magnetic field doesn't just flip, it breaks apart. During a reversal, the field can weaken to as little as 10% of its current strength. It can fragment into multiple poles. Imagine having magnetic north over Florida, another in the Indian Ocean, and a third near Antarctica. That's not just confusing for birds and whales, that's a death sentence for satellites, space stations, power grids, and even human health. Without a strong magnetic shield, Earth becomes vulnerable to solar storms. These storms, caused by massive ejections of charged particles from the sun, can fry electronics, cripple satellites, and melt power transformers. In 1859, a solar storm known as the Carrington event caused telegraph systems to spark and catch fire. If a similar event happened today, with our world wired together by sensitive electronics, it could cause global blackouts, cripple financial systems, shut down air traffic, and take years to recover from. Now imagine facing that kind of storm with a magnetic field at 10% strength. The damage would be biblical. But it's not just technology that's at risk. Our own biology is tied to the Earth's magnetic field in ways we barely understand. Migratory animals like birds, sea turtles, and even some bacteria rely on it to navigate. Disrupt their compass, and ecosystems could collapse. But the real question, one that keeps scientists awake at night, is what this means for humans. Some research suggests that prolonged exposure to increased solar radiation could lead to a rise in cancer rates, especially skin cancer. Others warn that the ozone layer, already fragile, could degrade further without the magnetic field's protection. And then there's the psychological toll. The human brain is an electrical machine, sensitive to electromagnetic fields. What happens when that field starts fluctuating wildly for centuries on end? And yes, centuries. That's the other chilling part. Magnetic reversals don't happen overnight. They take thousands of years. The transition period could span a millennium of instability. Compasses going haywire, satellites needing constant recalibration, global radiation maps redrawn again and again. We'd be living through a planetary identity crisis with no quick fix. Our modern civilization, dependent on precision, predictability, and connectivity, would be running blind in a magnetic fog. So are we doomed? That's the million-dollar question. The truth is, we don't know. We've never been here before. Modern humans didn't exist during the last magnetic flip. Our species, Homo sapiens, emerged around 300,000 years ago, which means we've never experienced a full reversal. And while the fossil record doesn't show mass extinctions tied directly to magnetic flips, those previous flips didn't involve a species that depended on satellites, navigation, and electronic infrastructure for survival. In other words, we're the first civilization in history to be this vulnerable to a change in Earth's magnetic personality. But not all hope is lost. Scientists are watching the magnetic field like hawks, mapping every shift, every anomaly, every dip in strength. Supercomputers simulate the core's turbulent dance. Satellites like ESA's swarm mission track magnetic changes with, unprecedented detail. And we're developing technologies that could help us weather the storm. Radiation-hardened electronics, smarter power grids, even early warning systems for solar flares. The key will be adaptation. Just as our ancestors once learned to harness fire and survive ice ages, we may be called to survive a magnetic apocalypse, not through brute strength but through resilience and innovation. And maybe, just maybe, this is nature's way of reminding us we are still guests on this planet. We build skyscrapers and launch rockets, but under it all, we're still dancing on a molten core, wrapped in a magnetic veil that we didn't create and we cannot control. It's humbling, terrifying, and honestly awe-inspiring. Earth's magnetic field is flipping, yes, but maybe the real question isn't, are we doomed? Maybe it's, are we ready? Because this is not a drill. The signs are there. The field is weakening. The poles are on the move. The countdown has begun. Whether it takes 100 years or 1,000, the flip is coming. And when it does, the survival of our species won't be decided by brute force, but by preparation, science, and, well, the will to adapt. The magnetic field may flip, but if we're smart, we won't. So, the next time your compass starts acting weird, or you hear about a strange satellite failure, or the auroras dance over cities they've never touched before, don't ignore it. Don't brush it off as coincidence. Because the planet is shifting beneath your feet, the sky is changing above your head, and the magnetic curtain that has shielded Earth since time began is being drawn back. And what lies beyond that curtain? That's the story we're about to write together. A story written in plasma, radiation, and resilience. Because make no mistake, the flip isn't a single moment in time, it's a chapter in Earth's ongoing saga. One we'll live through. One our children may grow up inside. One that could become the greatest scientific challenge of our age. And like all great challenges, it comes with opportunity. Opportunity to innovate, to rethink how we protect our digital civilization, and perhaps even redefine what it means to survive as a species tethered to a planet in flux. This isn't just a geological process, it's a wake-up call. Imagine a future where every building is shielded against solar radiation, where spacecraft are hardened for electromagnetic chaos, and where humans look up at flickering skies with awe rather than fear. We could see a golden age of magnetic technology. Compasses reimagined navigation, reinvented communication, rebuilt from the ground up. Cities could adapt with underground cabling and decentralized power systems, designed to withstand geomagnetic onslaughts. Schools may teach children not only how to code but how to navigate a world where north is no longer fixed. In many ways we might become more connected to the Earth than we've been in centuries, not just living on it but understanding its rhythms, its deep time, its silent warnings. And yes, there may be upheaval. There will be blackouts. There will be misinformation. There will be fear. But fear has always been the spark of human progress. We feared the dark, so we made fire. We feared disease, so we invented medicine. And now we fear the invisible collapse of our planet's magnetic armor. But that fear can drive us to greatness, if we listen, if we act, if we learn. Because the Earth is whispering to us now, not in words but in data, in shifting poles and subtle anomalies, in flickering auroras and failing instruments. We are not powerless, we have time, and we have something no species before us had during the last flip knowledge. Satellites above us, sensors below us, simulations all around us. We are watching the gears of the planet turn in real time. We may not be able to stop the flip, but we can prepare for it. Adaptation is survival, and survival in the end is what defines us. So maybe we don't need to ask if the magnetic field is flipping. Maybe the real question is whether this flip will flip us, our priorities, our technology, our relationship with Earth. Maybe this is the storm that births a new kind of humanity, one that doesn't take the sky for granted, one that realizes our greatest strength has always been our curiosity, our tenacity, our drive to make sense of the chaos around us. The magnetic field may change direction, but our mission remains clear: endure, evolve, and write the next chapter, not in fear but in awe. Because in the end, this isn't just the story of a magnetic reversal, this is the story of us.